All right, so welcome back. So now let's take a look at our demo involving the noun recall dataset. And for this particular set of lectures, I might encourage you to pause your video periodically to follow along and replicate what we're doing in our studio. And so first of all, let's get started by taking a look at the noun recall research question. So we're taking a look at a dataset called noun recall, and the research question was, is memory for sentences affected by the imagery being used in the sentence and also the complexity of that sentence? And so researchers recruited 80 individuals to take part in this memory study. Each person was asked to learn 30 sentences, and then after they learned the 30 sentences, asked to recall the subject noun. And so the test was to see how many of those subject nouns they could remember out of 30. And the participants were randomly assigned to 4 different conditions based on 2 types of manipulations. First of all, there was manipulation of imagery. So whether or not the participant was asked to use ordinary or bizarre imagery as they were learning the sentences. And then there were 2 levels of complexity of the sentences, low versus high. And so combination of these 2 different manipulations resulted in 4 conditions. And so when you look at this research question, what do you think might be the DV? So dependent variable would be the memory. So out of 30 sentences, how many of those subject nouns could the participant recall? And what are the independent variables? You might have said there are 2, the imagery and complexity. Great. So now let's take a look at the hypotheses. So what are the null hypotheses for the main effects? You might have said something like there is no effect. So imagery does not affect memory, and neither does sentence complexity. How about the null hypothesis for the interaction? So you might have started with there's no effect, and that makes a lot of sense. One way to say it would be that memory does not differ based on the combination of imagery and complexity. And then, of course, the alternate hypothesis for all of these would be the opposite, that there is some sort of a difference caused by the factors being considered. So translating that into our 2x2 table, here are the 2 factors. There's imagery, and then there's complexity, and each of them have 2 levels. And the main effects are comparing the means for those 2 levels within each factor. And so here is the main effect for imagery, bizarre versus ordinary, is being compared. Main effect for complexity, high versus low, is being compared. And then the interaction effect is trying to see whether the mean differences exist across these 4 combinations of factor levels. Before we jump into 2-way ANOVA itself, let me show you how to graph the means. There are 2 actual reasons why I'm showing you how to graph the means. First of all, graphing the means can be useful for eyeballing potential effects. So instead of just talking about the means and look at numbers, some of us are visual creatures and might benefit from actually eyeballing the potential effects so that you know what you're talking about. Also, if you have any significant effects and you need to report that in APA style, oftentimes having a figure is very useful. And so I want to show you how to graph the means so that if you need to write up a report of a significant factorial ANOVA, you know how to do so using figures. And we will explore the means of the 2 factors as well as the interaction. And so first, let's try to obtain some main effect graphs. And so what you want to do is to import and attach the noun recall dataset, and then go ahead and install and load the ggpubr package. And then after that, we'll run the ggline code to graph the main effects. And so here is where your data frame name would go. So chances it's going to be noun recall. And then the independent variable or the factor that you want to graph, and then the dependent variable, which is noun recall, so recall. And then you can add the rest of the code asking for the confidence intervals. And this defaults a 95% confidence interval. And so let's hop on over to our studio. Meet you there. All right, so here we are in our studio, and I have already imported the dataset noun recall. And so you can see it here. And then I've also attached it as well. And then I've cleaned up this area in order to make room for what we're going to do, which is to do the installation of the ggpubr package. And so you can either run this code or use this install button under packages. And so let's try running this code and see how it goes. Here we go. All right, so here we are, and then let me try running the library code, and it looks like it ran. And so hopefully that gives us access to the ggline code. And so without further ado, let's try running the ggline code that I'd written up here. And so here is the first one, which would be the main effects of imagery. And so what I'm doing here is to say, please give me the mean plots using a non-recall data set. And here is my independent variable, imagery. Here is the dependent variable, recall. And then please show me the confidence intervals, so 95% confidence intervals around those means. And so I'm going to run this code. Here we are. And so here is a graph of the means for the ordinary condition and then the bizarre condition for imagery. And so the mean recall is higher in ordinary than bizarre. And you can see that the means are kind of far apart, but then the confidence intervals are also pretty wide. And so it's not as though you've got ordinary distributed way up here and then bizarre distributed way down here. And so by eyeballing this graph, because there's so much overlap in the 95% confidence interval and so on, I can't really say whether or not there are significant differences between these two, but that is a possibility. Now let's try taking a look at a similar graph, but now for complexity. So let's compare complexity. And so now the means are seemingly kind of closer together, especially relative to the 95% confidence intervals for both high and low complexity. And so just eyeballing this graph, to me, it doesn't necessarily look like there's a main effect for complexity because the means of the 95% confidence interval look like they are very close together. So in terms of interpreting these graphs, just a note about what you might notice with the 95% confidence intervals around the mean. And so if they do not overlap, then you can tell visually that there's a significant difference. However, in our case, they overlapped. And so unfortunately, we can't for sure say whether or not there are mean differences. But if there were to be mean differences, then it looks like the one for imagery, the main effect of imagery appears to be more likely to be significant. But we will need to run the ANOVA to find out. Now you may be wondering, how do I do the interaction graph then? Well, great question. And so let's go and take a look at the ggline code for the interaction graph. And so you can technically have RStudio graph both types of mean differences in one graph. And so a way to do that is to use similar code, but this time you will add in another independent variable with a color equals statement, and then the rest remain about the same as what you've seen before. And I have these pause buttons on my slides to let you know that it's a good time for you to also follow along in your own RStudio just for practice. And so please feel free to pause my video every so often to follow along and see if your RStudio produces similar results. All right, so meet you back out there in the funnest studio there is. All right, so let's party on by taking a look at the graph of the interaction effect. And so you notice that I've written down the ggline code here just as I had shown you on the slides. All right, let's try running it. Wow, isn't that beautiful? So here are those means that are graphed together so that you can see how the means for recall might look like based on the person's condition. And so technically there's complexity and imagery graphed together. But within each level of imagery, ordinary and bizarre, you will notice that the means are graphed separately for complexity, those in the high complexity condition here, and then a low complexity condition here. And RStudio connects the means for you based on the level of complexity that you have, so it's easy to see how the means may look for each type of complexity. And what you notice here is that the lines connecting those means intersect. And that's a kind of a nice giveaway suggesting that there may be a significant interaction here. And so, for example, if you see parallel or non-intersecting lines, then it's less likely that there will be an interaction. And so I've taken down those notes here that when you see the means graph for both factors combined, when you have parallel lines, then you can generally assume or expect that there won't be an interaction effect. Whereas if you have intersecting lines like we just did, then most likely there is some sort of a significant interaction between the two factors. And so just based on our exploration, I am thinking that there may be a possible main effect for imagery. There probably isn't the main effect for factor B, And then there may be a possible interaction effect for those two factors. Now in the next mini lecture, it will be the moment of truth where we find out whether my expectations are correct or not. And so let's pause for a second for a quick review and a break, and then I will meet you back here to talk more about how to actually run your two-factor ANOVA. See you shortly. Enjoy your break.